Hello dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today I will discuss about the moving grate incinerator. In the last class I have discussed about the incinerator and designing of incinerator. After that the types of incinerator, and now we'll discuss in detail about this moving grate incinerator. So first of all we'll go with a basic definition of this incinerator. Incinerator means a furnace, a big chamber which has been designed to conduct for the burning of hazardous material in a combustion chamber. One combustion chamber is there. In that combustion chamber the waste has been burned, and due to burning of and this combustion chamber has been used for the burning of hazardous waste material. An incinerator can be defined as the process of burning hazardous material at a high temperature, that is too much high that will be enough to destroy the contaminants of the waste. So basically this incinerator has been used for the hazardous waste, so that the hazardous waste will be the contaminants in the hazardous waste will be burned out, and in this way it will destroy all the contaminants. And it has been conducted in an incinerator. Incinerator is a kind of chamber, or we can say that it is a kind of furnace that has been designed for burning of hazardous material in a combustion chamber. So combustion chamber is there. You can see these two type of combustion chamber is there. So combustion chamber has been designed to burn the waste, and this at a very high temperature, and that temperature will be applicable, and it will be enough to destroy the contaminants. And it is conducted in an incinerator. This is called as a furnace also, and it has been designed for the burning of hazardous waste material to destroy the contaminants in the hazardous waste. So this is the actual meaning and basic introduction of this incinerator. An incinerator is of a kiln type incinerator, moving grate incinerator. So today we will discuss in detail about this moving grate incinerator, because this is mostly adopted. This type of incinerator is mostly adopted. So the conventional mass burning based incinerator is a moving grate incinerator. It will consist of layered burning of waste on the grate that transport the waste through the furnace. So this conventional mass burning incinerator is basically based on the moving grate incinerator. That's why this incinerator has been commonly used, this moving grate incinerator. This mass burning of waste is based on the moving grate incinerator, and this incinerator will consist of layered burning of waste on the grate. It will consist of a layered burning of waste on the grate that transports the waste through the furnace. So layered burning of the waste is there in a grate, and that grate is going to transport the waste through the furnace. And then what happened? An overhead crane is also there. That crane can feed the waste into the hopper, where it is transported via the chutes to the grate in the furnace. So an overhead crane feed is there. With this overhead crane feeds the waste into the hopper. Waste is there in the hopper. Waste into the hopper is there. The hopper. So waste is already there in hopper, and a crane is there. That crane is going to feed the waste, and it can be transported via the tubes to the grate in the furnace. And on the grate, the waste is dried and then burned at a high temperature while air is supplied. So on the grate, the waste is dried. The waste is going to be dry, and it will be burned at a high temperature while air is supplied. So this is a basic basic techniques behind this moving grate incinerator. And this moving grate incinerator is nothing but consists of a layered burning of waste on the grate that transports the waste through the furnace. And after that, what happened? An overhead crane feed is there, and the waste into the hopper, where it is transported by the chutes to the grate in the furnace, where it will be transported by the chutes to the grate in the furnace. On the grate, the waste is dried. On the grate, what happened? The waste is dried and then burned at high temperature while the air is supplied. So this is the basic meaning of this moving grate incinerator. Now comes to its designing. When we will discuss about the designing of this moving grate incinerator, you can see the vehicle is there. The vehicle is bringing the waste, and here the overhead crane is there. That crane is pulling the waste and putting it into this chutes, and by the chutes it will enters to the drying grates. Grate is there, that grate is going to be drying. In the furnace, inside furnace it will happen, and in the burning grates the combustion chamber is there. Combustion chamber is also there, and the residue removal one tank is there, and here the fly ash will be removed. So by the burning of this hazardous waste, by the burning of hazardous waste, contaminants will be removed. So what contaminants is there? That contaminants is called as fly ash. Fly ash. So this fly ash has been collected in the bottom of this moving grate incinerator. And next is the gas cleaning arrangement is there. Next is what happened. Gas cleaning arrangement is there. In this you can see one fan has been adopted with the stack is also there. From the stack, the waste, the air pollution control devices has been installed. Air pollution control devices has been installed. So with the devices, the air should be cleaned, and the clean air can be enters into the atmosphere. So this is the actual picturization of this moving grate incinerator. Next point is what happened in this incineration process. So the ash, which is like the non-combustible waste fraction is there, it will leaves the grate via the ash chutes, and the bottom ash or slag drops from the end of the grate into the water traps of the slag pusher. So the bottom ash is there. Bottom ash, they will make a slag drops from the end of the grate into the water traps of the slag, and the slag is cooled by the contact with water. Then when what happened, the slag has been cooled. Slag has been cooled by the contact of water. So, and then what happened, the large piston pushes the slag for the conveyance system, and the fine particle and materials with a very low melting point, it made drops through the narrow gaps between the elements of grate, which constitutes a minor part of solid residue, that is 1 to 5% of the ashes. And the fine particles are there, and some material are there, that material is having a low melting point. This may drop through the narrow gaps between the elements of the grate, which constitutes a minor part of solid residue, that is 1 to 5% of the ash. The flue gas from the furnace consists of minor parts of ash and fly ash. As I have discussed, from the furnace, flue gas will come, and that flue gas consists of some part of fly ash and some part of ash is also there. Now, what happened? This is the advantage and disadvantage associated with this moving grate incinerator. Advantage is that it can accommodate large variation in waste composition and in heating value. It can accommodate large amount of waste and variation also. And next point is that it can build in a very large unit. It can build in a large unit. And disadvantages is like that the plant's installation cost is high, and the maintenance cost is also relatively high. So it is not cost benefit, not cost effective. Okay, so let's start with the plant designing and its layout. So now we are going to discuss about the designing of this moving grate incinerator, how this moving grate incinerator has been designed and what will be the layout. So this moving grates are there. This grates has been worked on two principles. It has two main purpose. First is to transportation, mixing and leveling of the fuel waste. First is it's a transportation of waste, mixing and leveling of waste. Next is the supply and distribution of primary combustion air to the layer of waste. Supply and distribution of primary combustion air to the layer of the waste. Next, what happened? This grate will make work on the two principles. First is the transportation, mixing and leveling of the waste. It will transport, mix and then level the fuel waste. And then what it will do? It will supply and distribution of the primary combustion air to the layer of the waste. Various grate designs are available. Many designs are there, and that designs has been characterized by their respective principle of fuel transportation that I will show you in the next picture. So this is the picture that will be related with the grate designs. So first of all, you can see this one is a roller grate. many type of grate design has been adopted now. So first is the roller grate, then bottom ash will be collected here like this. Rocking grate is there, rocking grate and roller grate. So roller grate, what happened? In this forward pushing of grate is there, waste will come and then forward pushing of grate, and like this bottom ash will be collected. In that rocking grate, what happened? Reverse pushing of grates, and waste will enter and flue gas will come, and by the reverse pushing of grates. Next is the horizontal grates. In horizontal grate, again waste will enter and then flue gas will go out, and the bottom gas will be collected into the bottom. So these are the different types of grate design. First is like roller gate and rocking gate, and roller gate is like forward pushing of grate, then the reverse pushing of grates, horizontal grates, and in this like of primary air will come, and that air, you can see this is the picture of roller grate, how waste will enter and flue gas will be there, and this will be the primary air and bottom ash will collected here like that. Next is again it is like waste will come, flue gas will go out, and the primary airs are there and the bottom ash will be collected here. So in the bottom ash collection chamber is there. So this picture represents the designs of the grate designs which can be adopted in the incinerator types. Now comes to the grate lengths. What happened with the grate length? How much length of the grate is required? So maximum of 65 to 70% of the grate length is applied. 65 to 70% of the grate length is applied as a drying and combustion zone. In the drying and combustion zone when operating in the design point at nominal load. So maximum of 60 to 75% of grate length is there. This has been applied as a drying and combustion zone, and the remaining length should be available to ensure final combustion and complete burnout of the slag and the ash. Remaining length which will be remains. So this length should be available to ensure the final combustion and complete burnout of the slag and the ashes. And next is the grate air supply. So in grate air supply, what happened? The high variation in load and heating value requires a very flexible primary air supply. In high variation in loads and heating value, it will requires a very flexible primary air supply system in respect to both the amount supplied and the supply spots. So this is like called as grate air supply. In grate air supply, what happened? The high variation in the load and heating values requires a very flexible primary air supply system. Very flexible primary air supply system in respect to both the amount supplied and the supply spots. In this way, the grate air supply will work. And next is the hand grate length. So the length for this moving grate incinerator, grate length and grate air supply is the two main important points while designing this moving grate incinerator. So for grate length, it will be like 65 to 75% of the grate length is applied as a drying and combustion zone. Next is the remaining length should be available to ensure final combustion and complete burnout of the slag and the ashes. And what happened to the grate air supply? The high variation in load and heating values required a very flexible primary air supply system in respect to both the amount supplied and the supply spots. And what happened with the grate air supply? Air supply will work like that. The primary combustion air should be supplied to the waste layer through small slots in the front side of the grate bars. So from the primary combustion chamber, the air should be supplied to the waste layer. And through small slot in the front side of the grate bars. Or through 1 to 2 mm slots between the grate bars. By 1 to 2 mm slots on the grate bar, between the grate bars, the primary combustion air should be supplied to the waste layer through small slot in the front side of the grate bar or through 1 to 2 mm slots between the grate bars. And what happened after that? The air supply area should be maximum be 1.5 to 2% of the total grate area to ensure satisfactory air distribution. Air supply area should be, it is like of the maximum, like 1.5 to 2% of the total grate area. to ensure the satisfactory air distribution. And the rate of air supply through the slot is 10 to 15 meter per second. So this will be like grate air supply. How means which amount of air should be supplied, what is the rate of air supply, and the air supply area should be maximum of 1.5 to 2%. And then the grate bars are there through which 1 to 2 slots between the grate bar are there. So primary combustion air should be supplied to the waste layer through small slots in the front side of the grate bar, or through 1 or 2 slots between the grates and the bars. Air supply area should be maximum be like 1.5 to 2% of the total grate area to ensure satisfactory air distribution. The rate of air supply through the slot is 10 to 15 meter per second. So this is about the grate air supply. So in this grate air supply, waste layer are there and some slots are there, and whatever will be the like 1.5 to 2% is the maximum total grate area should be air should be supplied. And the primary air combustion should be supplied to the waste layer through small slots in the front side of the grate bar, like through 1 to 2 slots between the grate bars. Next is the furnace design. How the furnace should be designed. Like the furnace is the main thing, because flue gas will flow through the furnace only, and the whole reaction, the whole combustion process will take place inside the furnace only. So the furnace should be designed in such a way that the long retention and reaction time of the flue gases at high temperature should be ensured. So it can be designed in a way that the long retention and reaction time of the flue gases at high temperature is ensured. And the furnace temperature is usually is in between the interval of 1000 to 1200. 1000 to 1200 degrees Celsius. The furnace temperature is usually in the interval of 1000 to 1200 degrees Celsius. Flue gas velocity in furnace is maintained at the lower level, like 3.5 to 4 meter per second. So this flue gas velocity in the furnace is maintained at a very lower level, like 3.5 to 4 meter per second. And the furnace section depends upon the flue gas flow direction, like the co-flow or counter-flow or mid-flow. Like the furnace section depends upon the flue gas flow direction. See, this is a which direction it comes to in the same direction, so it is called as co-flow direction. Next is the counterflow. Counterflow means what? It will be opposite side of the flue gas. So it is like that. So it is called as counterflow, this one. And this is like a mid flow. It is flowing in the mid. So the furnace will depends upon the flue gas flow direction. Which direction the flue gas is flowing, because in which direction the flue gas will be flowing, the flue gas velocity can be maintained lower than 3.5 to 4 meter per second, and the furnace is having a very high temperature, that is it usually interval of 100 to 1200 degrees Celsius. So this is a description about the furnace. And now we'll discuss about the flue gas recirculation. So after the dust filter, next part will come. That part is called as part of flue gas. Part of flue gas is there, that is 20 to 30%. It may be extracted and returned to the furnace. So after the dust filter, some of the flue gas may be returned, or it will be back towards the, maybe extracted, or it will be returned back to the furnace. So the flue gas recirculation has an operational as well as economic and environmental advantages. So this flue gas circulation, because this flue gas circulation has been related with it has some advantage, that is either economically and environmentally advantage. So economically, what happened? The recirculation of flue gas may leads to a higher thermal efficiency through a reduction of the excess air, hence the oxygen content. Recirculation of flue gas may leads to a high thermal efficiency through a reduction of the excess air and hence the oxygen content. An increase of the efficiency of 1 to 3% may be achieved. Increase in efficiency of 1 to 3% may be achieved. The efficiency should be achieved. Or reduction of NOx formation. Reduction of NOx formation like 20 to 40%. With 20 to 30% of the flue gas recirculation. So there is a reduction of NOx formation. So this flue gas recirculation will play a very important role economically as well as environmental advantage, because it will increase the efficiency and it will reduces the NOx formation also. Next is the reduction of the amount of flue gas entering the flue gas cleaning system. Reduction of the amount of flue gas, reduction in the amount of flue gas, reduction of flue gas and NOx reduction also there, and NOx reduction is also there. So this reduction of NOx formation, flue gas recirculation, reduction of the amount of flue gas entering the flue gas cleaning system. And next is the energy recovery system. So final step will come in this type of incinerator is energy recovery system. How this energy will be recovered? So energy released from the incineration leaves the furnace with a flue gas at a temperature of approximately 1000 to 1200 degrees Celsius. So energy released from the incineration leaves the furnace with the flue gas at a temperature is like 1000 to 1200 degrees Celsius. Next, what happened? The hot flue gases are cooled using boiler before passed on to the flue gas cleaning system. So hot flue gases are there, and that gases will be cooled using some boiler before it will be passing through the gas cleaning system. So in the boiler, the energy released from incineration is recovered as hot water or steam. Energy recovered either as hot water or steam, depending upon the types of boiler. The steam thus generated could be used to generate power. So this steam that has been generated, it can be used to generate power. So this reaction will occur. From heat, steam will come, and that steam will generate the power. So in this way, we can see that we have used waste as a fuel. Waste, by the burning of waste, heat will come, and that heat will generate the steam. With that steam, power will be coming out. So this is the ultimate goal of this incinerator that has been achieved at the end of this energy recovery system. So this energy recovery is the main important point of this incinerator, and the energy recovery point of view, it has been achieved. Now, this is the summary of typical efficiencies in different energy recovery systems. So, in heat only, if only heat is there, then the recovery is a 75 to 90%. Overall efficiency, you can say that is 75 to 90%. And if steam only, if only steam will be coming, then also the energy recovery will be like that only. If only power will become, then it will be less, that is 25 to 30%, 35%. Okay. Combined steam and power, that is steam and power. So this will be also like 60 to 75%, then 75 to 90, then 15 to 20%. Combined heat and power, then what happened? Combined heat and power will become then this much of energy efficiency. So 80 to 92 is more than 100. Efficiencies are defined as useful energy output from boiler relative to the energy content, like lower heating value of the waste, and B is the with the flue gas condensation. Okay. Now comes to the next point, waste incinerator plant in India. So we will discuss one waste incinerator plant has been installed in India, but that has been failed. That has been shut down because of some reason. So what happened in the 1987, the Ministry of Non-Conventional Energy Sources, MNES, Ministry of Non-Conventional Energy Sources, has commissioned a Timarpur refuse incinerator cum power generator plant station at a capital cost of 20 crore. At a capital cost of 20 CR, this has been imported from the Volume Mosaic Limited Company of Denmark. With the buying from the Denmark, the plant has been established in the Timarpur, and that plant will cost up to 20 crore. So next, what happened? It has been designed to incinerate 300 tons of municipal solid waste, 300 tons of MSW per day to generate 3.75 MW megawatt of electricity. The plant was shut down after 21 days of supply due to the poor quality of incoming waste. So this plant has been shut down after 21 trial day because of poor quality of incoming waste, means no proper pre-treatment of the waste. With no proper pre-treatment of the waste, Due to that reason, this plant has been shut down after 21 days of trial operation due to the poor quality of incoming waste. So this is the scenario of waste incinerator plant in India. It has been established in the year 1978, in 1987 by the MNES. MNES is the Ministry of Non-Conventional Energy Sources, and at a cost of 20 crore it has been installed, and its total capacity is 300 ton MSW, that is going to generate 3.75 megawatt of electricity. But this plant has been shut down after 21 days of trial period because of the poor quality of waste only. So what happened? The calorific value of the supplied waste was in the range of 600 to 700 kilocalorie per kg, while it required waste with net capacity calorific value of 14 to 1462.5. So the calorific value should be high. So attempt to supplement the combustion with diesel fuel is also fuel. So the calorific value is important. This plant will require fuel with a calorific value of 14.625 kilocalorie per kg. But our waste will have a calorific value is between the range of 600 to 700 kilocalorie per kg. So what happened? This some attempts has been there to supplement, to add some auxiliary fuels also, but it has been also failed. The ministry incurred an expenditure of rupees 1.25 crore on maintenance and insurance of the plant, but this project was officially shut down in the July 1990. So with this lesson, we have added some of the consideration while designing an incinerator plant. So what will be the important consideration for the installation of MSW incinerator plant in India? Incineration is most relevantly for the dry bins. Means dry bins is important, so there are content of 2 bin system. Pre-treatment is necessary for unsegregated waste. Pre-treatment unit is must because our waste is unsegregated waste, and the lower calorific value of the waste is must be at least 1415 kilocalorie. 1415 kilocalorie. So, and this is 6 megajoule per kg throughout all season. Means the lower calorific value LCV of the waste is approx 1415, and the annual average LCV must not be less than 1700 kilocalorie. It must be not less than 1700 kilocalorie. The furnace must be designed with best available technology to ensure stable and continuous operation and complete burnout of the waste and flue gases. So this furnace should be designed with the best available technologies. It has been defined. Some good technology should be adopted to ensure stable and continuous operation and complete burnout of the waste and flue gases. Next is like next point. What happened? Segregated waste supply should be stable, amounting to at least 500 TPD, and the skilled staff is required. Maintenance of the incinerator, since capital investment is high, so the planning horizon should be 25 years. So the planning horizon should be 25 years or more. A pre-feasibility study should be conducted. Strict monitoring system should be followed. So these are some of the consideration for installation of MSW incinerator plant. Main thing is the lower calorific value of the fuel should be 1400 around, and the pre-treatment is very much required, and the skilled staff is required for the maintenance of an incinerator. Since the capital investment is high, so the planning horizon should be 25 years or more, and pre-feasibility study should be conducted. Strict monitoring of systems should be followed. So this is about the some of the considerations, some of the important point why that should be keep in mind while designing an incinerator plant. And these are the references of some of the textbook which you can use to follow for your this depth study. And thank you for today's lecture. And today I at this point I want to conclude my lecture with the point that we have discussed about the moving grate incinerator and why India's first incinerator plant has been failed, and what are the important considerations while designing an incinerator for India. So if you have any queries or any question regarding this lecture, you can write in the comment box, or you can directly mail me on my given mail ID shikha.pandey@gmail.com. So thank you for this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.